See, this is what we did the other day. So the case is with the test hypothesis, a situation would be created. Okay, so there is going to be a claim that we're going to check. That was the body temperature that we did the other day. Then we set up the H0 as equality and the H1. That's a step one. Then the step two was using a machine. We call it test statistic. This test statistic can be Z or can be T. Depends whether the sigma, population standard deviation, is given to you or not. So the one that we did the other day, in the old cases, the sigma was given to you. So when you want to find the probability or the p-value, we end up with the z-score. Okay, we end up with the z-score, and just we did whatever we used to do for the z interval. And then we identify the probability. If the probability was less than alpha, we reject the H0. Otherwise, we do not reject the H0. Now I'm going to give a couple of examples that the case that the sigma is not going to be known. Okay, sigma is not going to be known, then you cannot use the Z test. Then you have to use the T test. Okay, so let's check how we're going to do the T. You have two choices to find the p-value for this one. You can use your calculator, or you can use the T table that I talked about it, that I gave you before. So let's start with so these examples are going to be the one that involve the T distribution. Okay, so this is going to be the example. So this example related to the T test. It's going to be related to the T test and the case that the sigma, sigma is unknown. Sigma is unknown, and or the sample size is very small. When the sample size is less than 30, whatever standard deviation is given to you, if sigma is not given to you, so that the standard deviation considered to be the sample. Okay, so for the first case, suppose we have this claim that we want to test. Okay, so a claim is given. And the claim is that the mean IQ of a statistics professors, the mean IQ, the mean IQ score, mean IQ score of a statistics professor, okay, a statistic professor, okay, statistics professors, for example, is greater than, is going to be greater than 118, greater than 180. So that would be the claim that we have to test it. So we need information. So the data information would be given to a sample information. We pick a sample and we check it. So it's going to be sample data. The sample data involves the sample size. So we check 20 professors and we find the mean IQ. The mean IQ is happen to be 120. Okay, and the sample standard deviation S, not the sigma, S for this group is 12. Okay, and the number that you see that is greater than 118. So we want to test this one by the significant level of alpha. Alpha is given to, the alpha is 5%. 5%, which is going to be 0.05. Okay, so this is the claim and this is the sample information. So you have to set up the test, hypothesis testing, okay? So the solution is going to be, this is going to be your solution. Okay, it's a test hypothesis about the mean. So you start with the H0. So the H0 is always goes with equality. The fact that the mu is equal to that specific number, which is 180. When we set it up, always, we We consider the H naught as an equation. Then what is going to be H1, the alternative? Alternative, we check this one that the mean IQ is greater than 118. So it's going to be the fact that the mu is greater than 118. Okay. So as you can see, since greater than, you have a right tail test. So the name of the test would be a right. Okay, so this is the right tail test. This is step 1. Step 2, you have to bring the tool. Okay, our tool is going to be this is going to be test statistic. So you have to decide which test statistics are going to use. So that would be test stat, test statistic. So test statistics depend on the sigma. Sigma is not given to you. So this means you cannot use this test. Okay, so you noted that the sigma is unknown. Okay, sigma is unknown and S is given. And sample standard deviation is given to you is equal to 12. So the t-test should be applied. Okay, so that's for your information. You realize that the t-test, okay, that's the t-test that should be applied. T-test should be applied. So you're not going to go with the Z, you go with the T. So your T0 would be equal to, it's going to be equal to the X bar, okay, minus mu or mu naught. But over it is going to be S, okay, S over radical N, not sigma over radical N. So we substitute together, the X bar is 120. So this is going to be 120 minus the mu naught. Mu naught is the number 180, 118 divided by S, which is 12, and then divided by the radical N, the sample size of the 20. Okay. I'll continue on the top. We simplify it. This is the way I got it. You see the top would be 2. You can do all of them at the same time, but I just give you the hint. So the bottom one, I use 2.683. And if you divide it, you arrive at the 0.745. Okay, so this is going to be the T naught. So the T naught is going to be 0.745. Any question? So that's a T naught. Now you have to find the probability, p-value. This is where it's different from the other one. Okay, so the next step is what's going to be the p-value, probability. So you check to see what type of test do you have. You have the right tail test, okay? So this is going to be right tail test, right tailed test. So officially the probability is going to be, you see P is equal to P of, less than P of T to be less than T naught. Less than T naught, which is the same as the P of T to be less than 0.745. We have two choices. The one that we're going to use, you see, in the case of the p-value, since you want to compare the p with the alpha, you don't need really the exact value of the p. You should be able to compare it with the alpha, which is 5%, to find out which is going to be greater than or less than. You can easily use the table that we have. Remember that T table. This is your T table. You see, the way we used the T table before, this part is the degree of freedom, which is n-1. And we just use this part in order to get the TC, or the confidence interval. For this part, we are going to use the first two lines. You see the first line is called one tail area, and these are alpha. Okay, one tail area, this is alpha. For example, this is 2.5%, 1.25, 10%, okay, 7.5, etc. So this would be the alpha for the one tail area, right or left. And this is going to be for two-sided one. Okay, so the DF, you know it. This is going to be the DF, and the alpha, that's going to be either in the first part or the second part. Now, the way we are going to do it for this problem is we just finding the DF first. You see, this is a situation that we have over here. So your sample size n is equal to 20. You see the sample size n is equal to 20. And the alpha that you want to check is 5%. 5%, which is going to be 0.05. So you are going to find the DF. You see the DF is going to be equal to 20 minus 1, which is equal to the 19. So what we're going to do, you are going to go to the table. You see, identify the DF equal to the 19, and you move, and you match this one with the alpha on the top, equal to the 0.05, but in the one tail area, because it's a right or left, okay, in the one tail area. So this place is one tail area, okay, one tail area. Okay, and when you go, you see, look at this one. This is a situation that we have. Just bring another paper to explain it. You see the DF of what? DF of 19. So we pick the DF of 19. This is DF of 19. Okay, this is DF of 19, and these are the numbers that you have. Then what you are going to do is you are going to compare it with the alpha in the one tail area of the 5%. You should look at the top. If you look at the top, the alpha is here. In one tail area, this is going to be our alpha, 0.05. So you see the 0.05 and the 19, there's going to be a number here. That number is 1.729, okay? You identify this number, 1.279. You see this number is going to be 1.729. Yes, that's it, 1.729. You see, this is going to be the number that, that's going to be kind of the origin for our argument. Then you compare the T0. What's the T0? The T0 is 0.745. You see your T0 is going to be equal to the 0.745. You see, this is 1.729. If you go to right, the number is getting bigger and bigger. If you go to left, the number getting smaller and smaller. So your number is 0.745. It's smaller. So this means you have to go to the left in order to get your p-value. So since you go to the left, you just go up in the alpha area, one tail area. This is going to be your p number. So your p number would be to the left of the 0.05. Just check any number to the left of the 0.05, okay, in the one tail area. Any number would be fine because you want just to compare them together. Look at this one. This is one tail area. This is one tail area, and this is 0.05. Your p number is to the left. Read any of these, the left one, compare it with the alpha. You see the first one is 0.7. Your alpha is 0.5. So this means p is bigger than alpha. If you pick any other, it's going to be the same thing. It's going to be 10%. Okay, so you have the alpha equal to the 5%, and your p number is to the left of the alpha. So compare it. Any number to the left of the alpha is greater than. So if you are going to be here, your p number is going to be 7.5%, which is going to be bigger than alpha. Okay, so you compare them together. The conclusion is going to be, that the p is greater than alpha. And you know that when p is greater than alpha, you do not reject. Okay, do not reject the H naught. Reject the H naught. It's a very easy method. You are not interested in the exact value, you see, because you want to estimate only. You're not going to be interested, so we just compare. Okay, so I repeat it again, DF is equal to 19, you move on, and you compare it with the alpha equal to the 5%, 0.05 in the table. And then this is going to be just, you pinpoint this point, then you bring your number. You see your number is going to be 0.745. So as you can see, 0.745 is a smaller number, so you have to go to the left. So this means your p-value is going to be to the left of the alpha. And you read any number to the left of the alpha, all of them are going to be, in this case, greater than alpha. So you read the first one. So you conclude that the p is greater than alpha, and when p is greater than alpha, you know that do not reject the H naught. Okay, any question? I'm going to show you the calculator as well. You have a choice. You can use either one to get it, but if you want to use calculator, you have to arrange everything up to this point. You can only find the p-value by your calculators. Okay, so finish it first. Do not reject H naught because you have to make the final comment. Do not reject the H naught means you like to keep the H naught. If you like to keep the H naught, you have to get rid of the H1. So this means you don't like the H1. When you don't like the H1, we say that there is not sufficient. Okay, so this is the conclusion. There is not. You have to write something negative for the H1 because you don't like it. There is not sufficient, okay, sufficient evidence to conclude otherwise, H1, to conclude that the mu is greater than 118. And that is exactly the claim, you see. The claim was, I should have write the claim here as well. You see, the claim was that the mean, okay, IQ of those professors are greater than 1/118. So as you can see, we cannot support it because we couldn't find the sufficient evidence. Okay, so we can say that refute the claim or do not support the claim. Okay, so do not support the claim, support the claim. Or you can say that refute the claim. Remember, you have to make a nice conclusion for this type of argument that you're going to have. Okay, so this is how we're going to deal with the t value, with the t-test. If you get a t-test, we are not interested in the exact value of the p, the probability. You should be able to compare it to see whether you are going to accept or you reject the, reject the claim. Any question? Now, if you want to use your calculator, you can use calculator only to get the p-value. Okay, and this is the way we are going to do it. I'm going to show you in case you want to use it. So this is going to be the calculator. You have to go to the distribution. Okay, remember that the variance, the variables and the distribution here. So the second and on the variables. So that would open up the test that we did before. Remember, normal, binomial, etc. So what you have to go to, you have to go to the t-test. Okay, this is t-PDF, no t-CDF. Okay, that is the number 6. That would be number 6, and then if you click on it, you see if you click on it, that give you the interval, lower, upper, and the DF. You get the interval because you see the p-value in this case for the right tail test. You have the fact that the p is less than 0.745. So less means this is a negative infinity and 0.745. So the lower number here is going to be a negative infinity, like the one that I have already. So it's a negative 1E99. And then I go for the upper. The upper is going to be the number that I have, which is a point. You see the number is 0.745, the T0, or Okay, then I have to give the DF, and the DF was in this case 19. So we get the DF of the 19. Okay, then you paste it and click. That's it. You see, this is your p-value, 0.76, very, very high number, 77% you get for the p. Your alpha is only 5%. So it's very much bigger. Okay, so if you use the calculator, you have to tell us that you have to set it up here. Okay, set it up here. So this is going to be only this part, the calculator result, if you like. For the calculator result, your p would be something like 0.77. And your alpha is just 0.05. And as you can see, your p is greater than alpha. And that was easily seen by the table. You didn't need to do this one too. But that's going to be the case if you want to use the calculator. That is how we're going to do it. But that table is fast, but we don't mind. Just both of them are going to be acceptable. Okay, any question? So that is with the one tail area that you have. You see, if you have a right or the left, it's going to be one tail. But we should give one example that the case that you have to use the two tail area of the table or the calculator. Okay, so let's give you one more example. There are going to be two cases that we are going to have. So let's see what we are going to do when it is the other way around. So I'll give you another example. Okay, I make this one brief. So what we want to do is we want you to use the T distribution table. Use the T distribution table to just find that p-value only. To estimate, okay, to estimate the p-value. The p-value of the each t-test. I'll just give you one because we have a couple of them in that review that we're going to do it. Okay, the situation is that is given to you is would like to have a two-tail test. Okay, so it's a two-tailed. It's going to be two-tailed test. Two-tailed test with this information, with the fact that the n is equal to the 18. It's given to you, and the alpha is equal to the 1%. And suppose you already find the T0, and the T0 is 2.32. Okay, we want just to talk about the p-value part. So I show you the table first. So the situation is the n is equal to the 18. You are going to find the df. So df would be equal to the 17. You move on. You have to compare it with the alpha equal to the 1%, which is 0.01. But where in two-tail area. You see the table that we have over here. Go back to the table. You see that's going to be the one. That's a two-tail area. You see this is where you have to check. And your alpha of 1% is here, 0.01. 0.01 is going to be the alpha. Okay, so as we did it for the other one, so we check this number first. Okay, this number gives you just a position to go to the right, to the left, to compare. If you check it in two-tail area, of course, two-tail area. If you check the number, the corresponding number is going to be 2.898. Okay, I can show you. This is df of 17. See, df of 17. This is a df of 17. Then you compare it with the alpha equal to the 1% in the two-tail area. If you compare it into the two-tail area with the 17, this is going to be the case, 2.898. Okay, this is the number. 2.898. So that gives us a direction here. But you compare it with your T0. So the T0 that you be given is 2.32. It's a smaller number. So since it's smaller, you have to go to the left to find your P number again. So your P number, your P is going to be here. The P is going to be to the left of the alpha, equal to the 1% in two-tailed area. So just check it. Read the first number that you can see. You see this is the alpha. This is the alpha of 1%. And you look at the number to its left is 0.2. Okay, 0.2. So which is going to be now, this is 0.2, but this is 0.1. It's a 2%. So P is again bigger than alpha. Okay, so in this case, the conclusion is going to be that the P is greater than alpha, and then you do not reject the H0. Do not reject the H0. And then nicely you'll be done. Okay, any question? If you want to use calculator, you got to be careful. It's a two-tailed area. You see, if you want to do the calculator, this is going to be the case. So for the calculator, you identify that your P is equal to the P of, okay, T not equal to the 2.32. But we talk about it, it's going to be left and the right. You can find one of them and multiply by 2. So this is going to be equal to the twice of the P to be less than 2.32. So you go and by your calculator, you find the T less than 2.32, and whatever you have, you multiply by 2. Okay, so if you want to do it with again, that's it. You have to get to the distribution. Okay, that was number 6. And in this case, it's okay, it's less than. So we go with the negative infinity again. This number is different. The number is 2.32 for the lower, 2.32, and then your you have 17 here, df of 17. So we change it to the 17, and then you paste it, and you get the result. You see, it's very high. 9.8, 98, 98%, and you have to multiply by 2 too. Okay, if you multiply by 2, you see, if you multiply by 2, that's the actual number. It's more than, it's nearly 200%. So as you can see, P is bigger than, okay? So that gives something like, if you go with this one, then the P is going to be something like 1.98, okay, which is much, much bigger than, okay, your alpha is only 1% or just 1. So as you can see, P is bigger than alpha. Okay, so if you have the calculator, you want to use it, you can use it, we don't mind. But this is only the place that you use it. You have to set up the problem and talk about everything you did so far. But otherwise, the table would take care of it. So you have nothing, nothing to worry about really for this one. Okay, that's it. Any question? So this is how we're going to check test hypothesis regarding the mean. So you are going to have 2 different cases, t-test and the z-test, and they give you one from each on this quiz, and whatever you do on this quiz is going to be repeated on the final. Okay, very, very soon. So we are ready to go over that practice quiz that I posted for you. Okay, so the quiz would be divided in 2 parts. The first part would be given to you. We have a confidence interval, 2 confidence interval, because you did a confidence interval for the mean previously, so we are not going to have the mean. But you are going to have a confidence interval for proportion and a confidence interval for the standard deviations and the variance, okay? And then the test hypothesis. So 6 questions is going to be kind of 2 confidence interval, and the 4 questions are going to be on there, okay, test hypothesis. Okay, so it's not going to be difficult. So let's try it. So this is the one that I posted for you. I'm going to go over it. Okay, that's a practice, and that's a practice quiz number 4, and it got 9 questions on it. Okay, let's see if we can do all of them for you. Any question? And this 6th question is going to be the 6th for the final. After your quiz, we have, I think, 2 lectures. So let me try to give you something else, just a short one, and then we review for the final. But I can post the final review so that you can see it. Okay, so this is going to be practice. Okay, practice quiz number 4. The first problem is going to be confidence interval for the proportion. Okay, I remind you, confidence interval for proportion or population proportion for proportion. The formula that you have is that P is going to be between P hat plus E and the P hat minus E. That's a confidence interval for the proportion, but your E is going to be, E is ZC, the square root of P hat Q hat over N, and your P hat is going to be R over N or X over N, and the Q hat is going to be 1 minus P hat. This is the formula that you need to be able to take care of the confidence interval for the proportion. So you read the problem and then you collect the information. Okay, the problem, you read it through to see what type of problem do you have. You see a survey of 300 union members in New York State reveals that 112 favor the Republican candidate for the governor. Construct the 98% confidence interval for the true population proportion. True population proportion of those people who are in favor of a Republican candidates. Okay, so you realize that this is a confidence interval for the proportion. You see, so this is how you check your problem. Say, oh, okay, I'm talking about proportion. So I need information, only 3 numbers. So I need sample data. The sample data start with the sample size. We talk about 300 union members. And R is number of successes, means the number in your favor. The favor is going to be supporting the Republican candidate, 112. And you want to check it with the confidence level of the 98%. That's it. So you need the E. So you begin only 3 numbers. The first 2 numbers, the bigger one is the sample size, the smaller one is going to be R. And the confidence interval is clear. That's it. You have your formula. So you have to find the P hat first. Okay, so we have to find the P hat first. P hat would be R over N. R is 112, N of 300. Okay, then you are going to simplify it using your calculator. Just bring the numbers that I have. This is number 1. Okay, if you use your calculator, I have a 0.37. So the P hat is going to be 0.37. Okay, that's a P hat. Then we have to find the Q hat. So the Q hat is 1 minus P hat, which is going to be 1 minus 0.37. Okay, and that gives you 0.63. So it's going to be 0.63. So the Q hat is going to be 0.63. Okay, you have to get the ZC. So C is going to be 98%. Then you go to that the bottom corner. Remember that we gave you already the table for this one. That is the bottom corner that we have. Okay, and the Z of 98%. Z of 98%, so that gives you 2.33. So ZC would be 2.33. Now we substitute E equal to, okay, E equal to, I repeat the formula for you, ZC square root of the P hat Q hat over N, substitute 2.33, the square root of P hat. P hat is 0.37, okay, times it by 0.63. Then you divide it by N. Okay, the sample size of the 300. Remember, they are all inside the radical. You simplify to take the square root. So this is how I arrived at my answer, 233, and that is 0.028. And if you get them together, so that give you 0.065. So E, marginal error, is equal to the 0.065. Okay, easy to find. Any question? Just make sure don't make a mistake. Some people, they make a mistake here. When they use their calculator, they take the square root of the top first, then they divide by 300, which is wrong. You have to multiply these two together, then divide by 300, then take the square root. Okay, make sure don't miss it. Now we are ready to give you the interval. So the interval is P between P hat plus E and the P hat minus E. Okay, so the P hat was 0.37, so that's a 0.37 minus a 0.065. So it's going to be less than P and less than 0.37, okay, plus 0.065. Then you put them together, and over here you get 0.305. And if you add it here, that gives you 0.435. Okay, so that's a proportion, but we express this one in percent because it's a probability. So we get 30.5% P, and you get 43.5%. Okay, so this is going to be the chance or the probability that you get the proportion. This means the proportion of those people who support the Republican candidates is going to be between 30.5% and the 43.5%. And you have to make a comment. Okay, so the comment is going to be, there is, in this case, there is a 98% chance that this is the situation, okay? Chance that, you have to make a comment, that the population proportion is going to be between these two numbers, between the numbers 30.5% and 43.5%, and then you that. Okay, so it's not going to be a complicated case. Confidence interval for the proportion. That was the first one. Any question? You have another one, we can check that one too for you. That's going to be the same category information that we have. So make sure get it done, and then of course you have to make a comment. What is going to be, what's going to be the conclusion that we're going to have. Okay, so that's number one. Are you ready? So let's quickly give you the solution to number two as well. It's the same topic, the confidence interval for the proportion. So this is going to be number two. So let's see what's the problem that I write it down for you. This is the problem for number two. We have 343 college students. We check and we find out that out of this group, 110 own a car. Okay, so 110 out of 343, they have their own car. So we want to find the 99% confidence, confidence interval for the population proportion of all the students that own a car. Okay, so you realize that's going to be a proportion problem. So you put the information together. Okay, so we realize that this is a proportion problem. So a P is missing. So what we have to do, we have to set up the data information, okay, to get these numbers. Of course, this is on the canvas, yes, it's not. So it's on the canvas, yes. Okay, so this is going to be the proportion. So we need the sample information. Sample information is going to be only 3 numbers. Okay, sample data. Start with the sample size, the total of students that we check, 343. We find out that out of these, 110 own a car, which we consider to be success, okay? And so we want to check it, find the confidence interval with the confidence level of 99%, 99%. So we have to find the E. Okay, this is a situation that we are going to have. Okay, so we set it up to get this number, to get the numbers. You didn't see it on the canvas? I'll check it. I think I posted to get these numbers. Let me check to see if it is. That is going to be the polymer. That is seems to be missing here. Okay, I thought I had it, so let's see if we can fix it. Don't know where I got this one. Okay, I have a copy here. I posted and I'll update it. It's the same thing, but it's called Math 103, but it's not. So you can have it. Don't know where I submit that one. So check now to see if you can see it on the on the front page. Can you see it? Oh, okay. Okay, then I changed the name. It's the same thing. Okay, so this is the one that I posted for you. Then I changed the 103 into the 120. Then I gave you, I don't know where I did posted that the other one. Okay, so getting back now to the one that I'm talking about. So this is number 2 that we are taking. So we have the 343 students, 110 owns a car. You want to find the confidence interval of the proportion of the people who owns the car, okay? So we have the sample information. So we know that the formula is going to be, the E is, we repeat the formula, is going to be ZC, the square root of P hat Q hat over, okay? We have the formula over N. So as usual, we have to find the P hat first. Okay, the P hat is going to be equal to the R over N. R is 110 and the N is 343. Okay, we can use your calculator to get this number. Okay, the one that I have is 0.32. Let's check it. It's a 0.32 for the P hat. Then we have to find the Q hat. So the Q hat is going to be 1 minus P hat. It's going to be 1 minus 0.32. Okay, so that gives us 0.68. So that would be 0.68. So we have the P hat and the Q hat. We have to find the ZC, C of 99, C of 99%. We go to that bottom corner table that we gave you. Okay, to find the 99%. For the 99%, it's 2.58. Okay, so that give you the ZC of 2.58. You get the same answer for this one too. Okay, so we have everything we need. So we go with the E. Okay, the E is equal to the 2.58. Now the square root of, on the top, P hat Q hat, it's a 0.32 times it by 0.68. Then you divide it by the total size, which is 343. Okay. If you check this one with your calculator, you get the same number, 0.65, 6.5%. So the E is equal to the 0.065. Okay, that's going to be the E, the marginal error. We just put it into the format of the formula. Okay, the confidence interval for the proportion is P is between P hat plus E and the P hat minus E. Remember your P hat is 0.32. So that gives a 0.32 minus 0.065 less than P less than, again, 0.32 plus 0.065. Okay, you put them together. I think this would be 25.5% or 20, that give you point. So should get 0.255 less than P, and this is going to be less than 0.385. To write it down in percent, so it's going to be 2.5% and 38.5%. So this is going to be the proportion of the population of the students who owns the car. So between 25.5% and the 38.5% of those people would have a car. But you have to make a comment. The confidence interval is 99%. So you just give a comment that there is a 99% chance that 99% chance that the population proportion, the population proportion, those people is going to be between, okay, it's going to be between 25.5%, 20.5% and 38.5%. Okay, and then with that. So that's it's not a difficult problem. The proportion is always easy. Okay, so that's the first topic. We give you two examples, but we give you one on the quiz, one on the final, for the confidence interval for the proportion. Okay, any question? Let's get another one before we give you a break. The next topic is going to be a standard deviation. Okay, this is the one that you have to find the chi-square to the right, to the left. Okay, that's what the main part is, finding these two. Okay, you cannot do it with your calculator. You have to show us, the way you are going to find it. Okay, this I'll go to the, okay, this type of problem. So we go to the number 3. You see this is the number 3. You read it true to see what's going on. So find the 90% confidence interval for the variance and the standard deviation. So you realize that this problem is confidence interval for the standard deviation or the variance. Both of them are the same. And then the 3 numbers would be given only. So find the 90% confidence interval for the variance of ages of seniors at Oak Park College. If a sample of 24 students has a standard deviation of 2.3. 3 numbers would be given: the sample size, sample standard deviation, and the confidence level. Okay, so you collect the information. So I just remind you what you need for these problems. So for these problems, the problems are going to be related to the confidence. Okay, confidence interval for variance or standard deviation, doesn't matter, for population. Okay, suppose, standard deviation, if you like, it's or the variance. We go with the variance first. Sigma squared is going to be less than and greater than. Over here, this is going to be n minus 1 s squared. S, the sample standard deviation, divided by the chi squared. Chi squared. This is right. You go for the chi squared to the left. So repeat it here. The top is going to be the same, n minus 1, okay, s squared, chi squared. This is left, you go with the right. This is for the variance. You find the variance and you take the square root. That would give you a standard deviation. Okay. Now the main thing, you have to find these two. Chi squared to the right, to the left. Okay, now how are we going to find it? We talk about it. So we collect the information first. What do you have? Sample information. Sample data. 3 numbers only. Sample size. Okay, they pick 24 students. Sample standard deviation, S. Sample standard deviation is 2.3. Confidence level, C, 90%. That's it. This is all you need and all you be given. Okay, we have to find the chi-square to the right, to the left. So this is it. We need a curve. This is, remember, the chi-square give you the area to the right. That's why you have to identify those cut points or the cut numbers. So what we have, we are going to break this curve, take out the 90% of the curve. Okay, then you have 2 points to identify. That would represent the area to the right. Okay, this is a 90%, the leftover will be 10%. So these two together are going to be 10%. You divide it by 2 to get each portion. So this portion over here is going to be 5%, which is 0.05. So the number over here is going to be the chi-square of this percent, if you like, 0.05. Eventually it's going to be chi-square to the right. Okay, then over here, you get to the right, how much, what percent? You see, this is the 90%, and you have an extra 5% here. So 90 and 5 would be, okay, 90 and 5 would be 95%. Okay, 95%. So this point would be represented by chi-squared of 95%. 95% would be 0.95. Okay, so in the middle, 90%. The leftover 10%, you divide the 10% into 2, 5% each portion. So this would represent 5%. The 5% in decimals would be 0.05. So this number is going to be chi-square of the 0.05, chi-square to the right. Then this is 90%. You add another 5, that gives you 5%. So this total is 95% or 0.95. So this number, that would be chi-square of the 0.95. Okay, then you go to the table to find it. Okay, so this is going to be the case. Now we need the table, the chi-square table. We are going to use it. Okay, so this is your chi-square table. You have to identify the DF first. Okay, your N is 24. So N is equal to 24. You find the DF, one less, is going to be 23. Okay, 23, and then you are going to move. Okay, that's 23. You move in this line over here, you see. That's your chi-square table. So the chi-square table, you identify the DF of the 23. You see, this is the DF of 23. So that's going to be the DF of 23. And then you move and you compare with the numbers on the top for the alpha. First number you are interested is going to be 0.95. Okay, and on the top, this is 0.95, 95%. So the corresponding numbers is going to be 13.095. You see, this is going to be the first number that you use, 13.095. Then you go move on to get to the 5%, and this is going to be your 5%. So the number correspond to the 5% is going to be 35.1992. Okay, so you bring these numbers here, and then you substitute to be able to move on. Okay, so let me just check with the one that I have. So that is going to be the case. So the first number is going to be, here's my numbers that I have. Just want to make sure they know I got it right. So the sample, yes, this is going to be the case. Okay, so they're going to be 2.3, and it's my number. Just put a sample. Yes, I got it. Okay, so the first number is 13.091, and so We got it over here. You see this number? This number is 13.091, and we continue to get to this part, and this is going to be 35.192. Okay, so basically, this means that your chi-squared, you see this is going to be chi-squared to the left, the chi-squared to the left 13.09, and the chi-squared to the right is going to be 35.19. Okay, 35, 1.72. That's a 7. Okay, 772. Any question? Go back, substitute here to get the confidence interval for the variance. Okay, so there you are. I repeat the formula. So I need the sigma squared. It's n minus 1 s squared, and that's a chi squared to the left. And this is going to be n minus 1 s squared, and that would be the chi squared to the right. Substitute n of 24, so that's going to be 24 minus 1. S is 2.3, 2.3 squared, divided by the chi squared to the right. Chi squared to the right, you have 35.172. So that's a sigma square, and repeat this number, 24 minus 1, okay, times 2.3 squared, and the number is going to be 13.091. Okay, use your calculator, that give you 3.46. 3.46 less than sigma squared, and this would be less than 9.35. You take the square root, so the sigma is going to be square root of 935 and the square root of 3.46. So take the square root, so that give 1.86 less than sigma and less than 3.06. This is going to be the confidence interval for the standard deviation. You make a comment on this one only, we accept that. The confidence level of 90%, so there is a 90% chance that the sigma is going to be here. So there is 90%, okay, 90% chance that the population standard, okay, the population standard deviation is going to be between these two numbers, okay, between 1.86 and 3.06, and then you're done. Okay, again, it's a straightforward problem, and you better use the table, unless your calculator would have those programs that I talk about it. So it's safe, you know, to just do it as is to get these numbers. Any question? So we have a couple of more. Let's see if because the 99% when they give you that number is tricky. Let me check. One of them must be. So that was number 3. Okay. We can check number 4. Okay, I'll give you a break now. You know, then we come back and we do the number 4, 5, and the other one quickly. Okay. That's it. It's 11:23, 10 minutes. We come back, we finish. We have one more standard deviation, and then we have to check 4 cases for the test hypothesis. So for the confidence interval, we get only 2 cases, proportion and the standard deviation. Okay, see you in 10 minutes. Okay, so let's see, quickly give you one part of this number 4, because it's a confidence interval for the standard deviation, but it's a 99%. Just make sure you get it right. Okay, number 4. They ask for the confidence interval for the population standard deviation, and the informations are given to you. So I'm going to put it together briefly, and checking that. Okay, just make sure you get chi-square to the right and the left. Okay, so the first part is this one: ages of drivers occupying the passing lane while driving 25 miles per hour with the left signal flashing. So we have a 99% confidence interval we want to find for the 27 drivers with a standard deviation of 4.6. Okay, so this is the one that I'm going to check. So that would be 4A. Okay, that is 4A. So the information is that we want to find the confidence interval for the standard deviation, so the sigma. So we need the sample information. So that's going to be sample data. We have, okay, the sample data, the sample size, N is equal to the 27. S is 4.6, okay, 4.6, and the C is 99%. Okay, C is going to be 99%. That's it. We know the formula, so we have to find the chi-square to the right, to the left. Okay, so this is it. So the curve is, you see, this area is 99%. Okay, so the left is going to be 1%. So the left is going to be 1%. So each portion is going to be half of the percent. Okay, so here you get a point, okay, 0.5%. Got to be careful when you change it to decimal, so it's going to be equal to the 0.005. And this is 0.5%. Okay, 0.5%, so this is going to be the same thing. So that's going to be 0.5%. Okay, so this is 5% and this is 90%. So this part over here, you have to find the chi-square of the 5%, 0.5%, which is 0.005. Okay, and this part over here is going to be the chi-square of the, you see this is 99.5%, which is going to be the chi-square of the 0.995. Just make sure to pick the correct numbers. Okay, any question? 99%, the leftover 1%, so half of the percent each part, which is going to be 0.005. So you go to your table and N is equal to 27. So N equal to 27, that gives you the DF of the 26. Okay, and you move on, you get to the first part or this number, and then to the second part for the other numbers. Just make sure you know where to 99.5 is. You see, this is your table, and this is 0.995. Okay, 0.995, and in this case, your DF was 26. You see, this is going to be 26. So that would be 26. When you go to 26, 11.160. You see, 11.160 is regarding the 0.995. Then you have to continue to get the 0.005. It's going to be the last one. So just keep going. The last number that we can see over here is going to be 48.29. Okay, so the first number is 11.16 and 48.29, the last number. Okay, so just make sure that you get it right. So the numbers are going to be 11.16 here, and this is going to be 48. Okay, 48.229. Okay, so that would be your chi-square to the left, which is 11.16, and this is going to be the chi-square to the right, which is 48.29. Okay, any question? The rest is just formula. You substitute, your formula is n minus 1 s squared over the chi-squared to the right, and that's going to be your sigma squared less than n minus 1 s squared, and that would be the chi-squared to the left. You substitute, that's n27, 27 minus 1 s squared, s is 4.6, divided by the chi-squared to the right, which is 48.29. This would be sigma squared, and this is 27 minus 1 times it by 4.6 all squared, and the chi-squared to the left, which is 11.16. Okay, use your calculator, and eventually you arrive at 11.4 less than sigma squared, and that would be 49.3. I think that's it. That's about 49.3. You can check it with your calculator, but I think that's correct. Okay, that's a variance, but we need to take the square root, 11.4, and that would be the sigma, and this is the square root of 49.3. And if you simplify it, you arrive at 3.38 sigma, and that would be 7.02. So this is going to be the confidence interval for the population standard deviation. Of course, you make a comment because this is 99%, so 99% chance that the answer is going to be this one. So you have to make a comment. There is a 99% chance that the population standard deviation, okay, standard deviation is between okay 3.38 and 7.02, and that gives you the final answer. Okay, so just to make sure you get this one right. And the part B is similar, so I just give you the final answer. You can check it for yourself. Okay, this is for the 4B. Briefly, this is the sample information that you have. That's going to be your sample data. You have the n is equal to the 30. Okay, and the sample standard deviation of 2.5, and the C of 90%. Okay, you can draw the table. It's like the first part. You must arrive at these chi-squares are the same that we did before. So the chi-square to the left is going to be 13.091, and the chi-square to the right, you are going to arrive at 35.1772. Okay, and if you put them together, this is going to be the sigma squared. It's a 5.15, and that would be 13.85. And you take the square root, 2.27, and this is going to be 3.72. Check it for yourself, but it's going to be the same thing. I just check this. The degree of freedom of 29. Yes, you have it and you get it. Okay. So that would be the problem for the population standard deviation or the population variance. One on the squeeze and one on the final. Okay, any question? So that's about the confidence interval. The rest are going to be those test hypotheses that we talk about it. So it's going to be only mean. So you read the problem carefully to see what's the claim. You identify the claim, the sample information, you set up the test. You have to explain all the 4 steps of the procedure that we're going to have, okay? Otherwise you lose points. Then at the end, you make a judgment. There are going to be 2 cases. If the sigma is given, you are going to use the z-test, okay, in order to get the p-value. If the sigma is missing, you have to use the t-distribution and the t-table or calculator to get the final answer, okay? It's a straightforward problem, really. The only part is that use the proper test. Okay, so that would start with number 5. You have to read the problem carefully, then come back and get your information. Okay, this is number 5 that we have. You see, they talk about the sample of 18 people with the income below poverty level. We check their mean daily calcium intake, and it's happened to be 747.4 milligrams. We want to check by using the 5% significant levels to find out, do the data, you see, read this expression, do the data provide sufficient evidence to conclude that the mean calcium intake of all the populations below the poverty that is less than 800 milligram. So you realize that the claim is this part. You want to check to see if the mu is less than 800. Okay, read it carefully. They just put it in this type of expression that we're going to have. Okay, so we realize this problem is test hypothesis regarding the mean, and the standard deviation is also given to you. Now you are ready to put them together and collect the information and set up the test and do the job. Okay, so read the problem carefully once to see what is the claim, and you have to identify the claim for us. So this is only the order of the solution. So this would be number 5. So you identify the claim first, okay? So what is the claim? The claim is that the mean is going to be less than 800 milligrams. This is the calcium intake. You need sample information, sample data. You know, we pick a group of the paper and we check this one. The sample size is 18. The mean for this group, sample mean, is going to be 747.4, which is less than 800. Okay, and you want to check it with the alpha equal to the 5%. But you do have the standard deviation, population standard deviations, 188 milligrams. That's it. Okay, so this is the information. You're now setting the test. Step 1, H naught. H naught is always an equality. E mu is equal to that specific number, 800. H1, alternative that we want to check, mu is less than 800. Okay, since it's a less, it's a left tail test. Left, that would be useful when you want to find the probability, the p-value. Left tail test. That is the step 1. Any question? Step 2, the machine. Test statistic. What is test statistic? Check sigma is given or not. Yes, it's given. So let's see test. Okay, this is the way you identify it. Sigma equal to the 188 is given, is known, is given, and so the test to be used is the z naught equal to the x bar minus mu over sigma over radical n. If that sigma is missing, you have to use the t-test. Okay, just make sure to get the correct the correct test to argue. Okay, is the left tail test because it's less than. You see, when it's less, to the left. When it's greater than, to the right. Okay, so substitute, get this number. You see, so this is going to be equal to x bar is 747.4 mu 800. You know that this is mu 0, in fact. Mu or mu 0. Okay, sigma is 188. Okay, the square root of n is 80. That's it. This is the only calculation that you are going to do for this problem. Okay, using calculator, you can easily find this number. It's a z number. You have to round it up to the 2 decimal places. So I have negative 1.19. Okay, that's going to be the z naught. Z naught is equal to the negative 1.119. That's a step 2. Any question? Step 3, p-value, probability, p-value. It depends what type of test you have. You have left tail test, left-tailed test. So the left-tailed test means, you want to find the probability that P is, probability that Z is less than Z naught, which is the same as the probability that the Z is less than negative 1.19. That's it. It's area to the left of the Z number from the table calculator. You can find it right away. Okay, this is it. This is the negative 1.119 left. That left would be the exact numbers from the T table, Z table. Okay, if you check the Z, you know that you can use it, use your calculator if you like, but with the Z is also easy to find. Just a reminder where you are going to find it. You go to your Z table, okay, and you identify it. So that's your Z table. Okay, you identify negative 1 point, you see this is negative 1.91, this is negative 1.901. Okay, what is that? Sorry, negative 1.1, negative 1.19, 1.9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's going to be 11 point, that's it, 0.1170. So that give a 0.1170, which is, 11%, 11.7%. So the p-value is going to be 11.7%. That's it. That's a p. Your alpha is only 5%, so it's very much greater than. Okay, so the last step is conclusion. The conclusion, P is 11.7%, alpha is 5%. So P is greater than alpha. When P is greater than alpha, you know that. Do not reject. Do not reject H naught. Do not reject H naught means you are in favor of the H1. Means you support the H1. Okay, and the H1 is mu is less than 800, which is the claim. Okay, so this is, I'm sorry. Let's see what's going to be the one. Do not reject it. Sorry, I made a mistake. Do not reject the H naught means you like the H naught. Okay, do not reject the H naught means you like the H naught. So this means you don't like you are not going to support the H1. So you have to write something negative for the H1. You see something negative means there is not. Be careful, to get this one. There is not sufficient. Okay, there is not sufficient evidence Okay, sufficient evidence to conclude that the H1 mu is less than 800 milligrams. So this means that was the claim, remember? So this means you do not support the claim, refute the claim. Okay, so do not support the claim. Support the claim. Okay, so the answer was no. You know, they ask you, is there any sufficient evidence to believe that the mu is less than 800 milligram? And the answer would be no. Okay, so this is going to be the way we're going to do it. And this is the complete solution for the test to get the full grades. Okay, some people, you know, the way they do it, they don't talk about any H0, H1. They give me just a couple of numbers. I put a question mark for you. You see, this is test hypothesis. You have to set up the test, give us the tools of the test. Okay, it's going to be quite a lot. In this exam, it's going to be 3 of those, but on the final, it's going to be something like 5 or 6. So make sure, you know, discipline your writing, because otherwise you lose quite a lot, you know, because nicely you have to, you know, you have to give a judgment, a logic, you see, just be precise to get these numbers. Okay, so that's about the left eye test. Any question? So there are 3 possibilities. You may get the right or get two-sided one. Let's see if you can do one more and then go to the T. So that was number 5. Okay, let's check number 6, which is another one for the mean. The sigma is given to you, but the case is different. Read it carefully. Number 6. Okay, let's go through it and I summarize it for you. So number 6, I start with this question. The question of how tall are, this is the one, how tall are hockey players? The average height is given to 68.3, a random sample of 14. Okay, random sample of 14 hockey players, give us the mean of 69.1. We may assume that normal, that, you just read the last expression to see what you want to do. Does this indicate that the population mean height is different from 68.3? Use the 5%. So the claim is that the mu is not equal to the 68.3. It's not, and that gives you a kind of a two-sided one. Okay, so the claim is mu is not, but we have a test. We check n equal to the 14, and the mean happened to be 69.1. So we want to check it. Alpha of 5%, and the sigma is already given to you. Okay, so read it through to find out what you want to do. Okay, so this is how you summarize the problem for yourself. So that's a number 6. So the number 6, the claim was, okay, so what's the claim? You want to check if the mu is not. Okay, mu is not equal to the 68.3 inches. Okay, that's the claim. But we have a sample information. So what's going to be your sample data? So the sample data start with the sample size. You see n. And we check how many players check? 14. And we find out that the mean height is 69.1, which is bigger than. Okay, or it's different. And we know that the sigma is given to us is a 0.9 inch. And you want to test it by alpha of the 5%. Significant. You see, C is for the confidence interval, alpha is for, okay, alpha is going to be for test hypothesis. There you are. So we're going to set up the test. We set up the test. H naught, as usual, is going to be a specific number. So the mu is equal to 68.3. H1 is the alternative that's given. You want to check if it is not. Okay, that would be two-tailed test because of not. Okay, so it's going to be two-tailed test. That's the step one. Okay, any question? Step two, the test statistic, the tool, test stat. Do you have the sigma? Yes. So the sigma 0.9 is given. So we have to use the t-test. And so z-test, z naught is equal to the x bar minus mu, or the mu naught, over the sigma over radical n, the z-test. Substitute x bar of 69.1, mu naught of 68.3, sigma of 0.9, square root of 40. Okay, use your calculator. You arrive at 3.83 almost. So the z naught is going to be equal to the 3.83. That's it. Any question? Now probability, p-value. You have two-tail test. See? So the probability, p-value, the test is two-tail test. So the two-tail test means the p is going to be probability that the z is not equal to the z naught. You see, we already talked about it. And this means that it's not equal to, you see, z is not equal to the 3.33. We talk about it for this one is, this is a situation we're going to have. So you're going to pick the 3.33 here and the negative 3.33 here. So these together is going to be your p-value. The portion to the right and portion to the left. So this would be half of the p-value, and this would be half of the p-value. So what we do, we are going to find one of them, we multiply by 2. We talk about it, this is better. Because for the negative one is area to the left, you directly read it from the table. But if you want to do this one, you have to find the complement, and it takes more time. So the p-value is going to be twice of the p of the, again, we can use your calculator as well. It's going to be p less than negative 3.33. Okay, so in this case, it's different. So we're going to have two portions over here, okay? And you can pick the right to the left, but the left is much easier. That's going to be one. That is going to be the one. Yeah, two-tail test is when it's different. When we describe it for you, okay, when we go over it, there are two cases only. Left or right is just one-sided. When it's a different, it's going to be two-tail test. Okay, so we go to the table and we find this number, negative 3.3. It's going to be a small percentage. Okay, so if you go to the table, you see negative 3.3. That's a 3.3. 3.33, you see 0, 1, 2, 3. You see this number? 0.0004. So this would be 0.0004. So your P number is going to be twice of this, 2 times 0.0004, which is 0.0008, very small number. Okay, so that would be the P. Any question? Conclusion, compare. Okay, we are going to compare to be there. You see what is the P? P is 0.0008, and alpha is 5%, 0.05. As you can see, P is very much less than alpha. P less than alpha, you reject the H naught. Reject the H naught. Okay, reject the H naught means you don't like the H naught. So you're going to be in favor of the H1. Okay, so you write something. H1 is the fact that the mu is not equal to the 6.83, which is exactly the claim. So you have to make something positive for the H1. So there is sufficient evidence. There is sufficient evidence to conclude that the other one, mu is not equal to the 68.3, because that's the H1. And this means you support the claim, because that's exactly the claim. So support the claim. So the answer in the question is yes. We support the fact that it is not going to be equal to the, okay, so this is the case for the Z. Any question? So we may give you one-sided and one with a two-sided here. Okay, we try to give you two from each for the T and the, because we have one confidence interval for the proportion, one confidence interval for the standard deviation, and 4 more questions. 2 questions for the Z, 2 questions for the T. So that's a 2 type for the Z. So let's quickly check the T as well. Okay, the T only, the difference is going to be when you find this, okay, the p-value. Okay, so that's number 6. So we go to the number 7, and this is going to be a T case, number 7. You see, in the case of the T, most of the time the exact sample would be given to you. You see these numbers. What is this? They talk about the food delivery. Okay, how long does it take to have food delivered? A Chinese restaurant advertises that the delivery time is not going to be more than 30 minutes. That's a claim on average. We want to check it. So a random sample of delivery time is going to be here that we have. So we check a number of them. Okay, here is 14 different cases, and these are going to be in minutes. So we want to test it. Is delivery time greater than 30 minutes? So the claim is that, is it mu bigger than 30? So we check it with a 5% case, okay? So you set up the problem, it's number 7. So there is a claim that you want to check. The claim is, because the company said is not. So they claim that it's going to be greater than 30 minutes. Okay. So you need to collect the information. You see the sample. You have an extra job. Sample data. You see the sample size N is equal to, we have 14 numbers. So you have to use your calculator and you find the X bar yourself. You know how to do it, just. So these are the numbers, you put it in the calculator, you find the X bar or add them together, divide by 14. So this is an extra job. So if you do it, that gives you 30.57. 30.57, so you have to find it yourself. And then you have to find the standard deviation, S, again by your calculator. That gives you 5.87. So you have to find these 2 numbers, okay? We give you one example that we give you these numbers, but the other one is you have to find it. Okay, so that give you the case. And of course, you have only S, the sigma is missing. And you want to check this one against the alpha equal to the 5%. Alpha equal to the 5%. Okay, so if the actual numbers are given, you have to find the X bar and the mean and the standard deviation yourself. The rest are going to be easy to set up. Okay. So to setting up the test, that's the claim that you want to check. So the H naught is the fact that the mu is equal to the 30 minutes. Alternative is the one that talk about it, greater than 30 minutes. It's a right tail test because it's greater than. Right-tailed test. Okay, you need the tool, test the stat, test a statistic. You don't have the sigma, you have only the sample. So you have to use the t-test. Okay, sigma is unknown. Sigma is unknown, and S is given to you. S is 5.67. So we have to use the t-test. T naught equal to x bar minus mu naught, but S over radical. The difference is this one. In the previous one is sigma over radical n, this is S over radical n. Okay, now substitute. Your x bar is 30.57 minus mu naught, which is 30. S is 5.67, radical n, radical 14. Okay, use your calculator to get this number. And the one that I have is point. So it's 0.346 or 0.363, that's one. Okay, so the T naught is equal to the 0.363. So that's going to be the T value. Any question? So we have a test stat, now P value. P value, you see, it's a right tail test. So it is going to be the P is going to be equal to the P of T, right, greater than T naught, if you want to use your calculator. It's going to be P of T greater than 0.363, which is T0. Okay, we talk about how we're going to find it. We go to the table. We identify the N is equal to the 14. You see N is equal to the 14. You get the DF of 13. You go on, you match it with the alpha. Alpha equal to the 5%, 0.05, but in one tail area. One tail area. Remember, that's a t-table. Maybe we did it. That's it. That is the one tail area. And this is going to be the 5%, 0.05. So we got your DF. DF is equal to 13. You match this number. Okay, look at this one. That's a DF of, okay, a DF of 13. You see, this is a DF of 13. DF of 13. DF of 13 in the one tail area on the 5%. You see the number that you see over here for matching is 1.771. It's not important, this number 1.771. That give you the idea of whether your number is going to be to the right or to the left of the, you know, the 5% that we did over there. So we identify these numbers that give us a 1.771. Then you compare it with the T0 that you have. Your T0 is 0.363. You see, compare them together. If you go to the right, this number is getting bigger and bigger. If you go to the left, the number is getting smaller than 1.7. Your numbers is smaller, so you have to go to the left. So this means your p-value is a number to the left of the alpha. Okay, we get this 1.77 to find out how do we go to the right or do we go to the left. Then if you go back and read any number to the left of alpha, you see that was your alpha in one tail area, 5%. You see any number to the left, even the first one, 0.7. 0.7 is bigger than 0.5. It doesn't matter. If you pick this one, you see, that's a 1, 2. All of them are going to be bigger than alpha. Okay, so you check the number to the left is 0.7. So this means your P is bigger than alpha. If you don't like it, you can use your calculator to find the exact number value of the value of the P. Okay, and you know that the P is bigger than alpha. P is bigger than alpha. So do not reject. Do not reject the H naught. Okay, do not reject the H naught means you like H naught. What was the H naught? Was the fact that the mu is 30 minutes. So if you like the H naught, so you are not going to like the other one. So this means you are going to reject the other one. That was the claim. So you are going to write something positive about the other one. Do not reject the H naught means you like the H naught. So something negative about the other one. So there is not sufficient evidence to conclude that mu is greater than 30 minutes. Okay, greater than 30 minutes. So this means you do not support the claim because that was the claim. Okay, refute the claim or do not support. Okay, do not support the claim to get these numbers. Okay, just make sure to get that P, that T value correct to get these numbers. Okay, so what's that? T naught, it's not important really, that number. The one that I got is, how did we get 0.376 for the T naught? Okay, just, check your calculator. 67 or 73, it's the same. Double check it if yours, it's very close. I have, double check it. 0.363, this is the one that I have, I didn't get time to check it. So yours is 0.37, just double check. But it's close, it's okay to get these numbers. Different calculator will give you a little bit different. Okay, any question? So just make sure that you understand how we're going to find the T over here to be given, the numbers. This is one type that we give you these problems. You have to find that standard deviation yourself. And there is going to be another one which is straightforward because that would give you the S would be given. Okay, so you have a number 8 that I won't get time to do it, so I can give you the numbers, you check it yourself. Number 8 is just a bunch of numbers about the price of the bananas. Okay, you want to compare them together. Okay, so this is number 8. If you want the information, this is how you're going to see how much time do we have. I may be able to do it. Okay, let me see if I can give you the numbers for this one. That was number 7. Where's the number 8? Lots of numbers here. I did have it. Okay, they just want to compare the price of the banana in the two different times. Okay, let me see where's the information about number 8, 7. Oh, okay, I got it. Yeah, I got this. You see, the story is this one. The story is that the average retail price for bananas in 1998 is 51 cents. Okay, so we want to check We go around 15 markets and we find the price. You see the price are, of course, they are all more than 51 cents. Okay, so they just want you to check this one. Okay, so can you conclude that the current mean retail price for banana is different from 1998? Oh, it's a good example, so I do this one. Okay, so the claim is that we want to know, you see, you have to read it right through the end to find out what is the claim. The claim is if the mean price of the banana, okay, is different from 51 cents, okay, 51 cents. So that's a claim that we have to check. We have a sample information again. You see the sample data. Sample data again is going to be involve the sample size. Okay, the sample size, we have 15 market. Then you have to use your calculator to find the X bar for this problem. It's going to be 53 cents, 0.4. Then you have to find the standard deviation. You know, double check this with your calculator. 3.5, and you want to check it against the alpha equal to the 5%. So again, your extra job is to find that mean and the standard deviation, okay? It's a good example because I want to show you that two-tail area, not two. So we go with the H naught. H naught is the fact that the mu is equal to the 51 cent. H1 is otherwise not equal to 51 cent. As you can see, we have two-tailed test. That's going to be two-tailed test. Okay. So we need the tool, test a statistic. So what's going to be test a stat? Do you have the sigma? No. When the sample is given to you, you have the sample only. So the sigma is unknown, sigma unknown. But we have the S, and the S equal to the 3.5 is given. So we have to go with the T again. So the T naught is going to be equal to the X bar minus mu naught over the S over radical N. That's S. You substitute. So the X bar is 53.4 minus mu naught of the 51. S 3.5 radical N radical 50. Okay, you check this one with your calculator. I have 2.655. Okay, that's going to be your T naught, which is going to be 2.655. Okay, so you know this is going to be the same thing for the other one, and just get the one. This is going to be the case. Okay, so that's going to be the T naught. So we have to find the p-value. So what's going to be the p-value? Remember, it's a two-tail test. So it's going to be two-tail test. You have to go to the two area for this one. Two-tail test. So you want to find the probability that T is not equal to the 2.655. Okay, so what you have to do, you know, you just get it from the table right away. So what we do is the sample is 15 and is equal to the 15. So we find the DF is equal to the 14. Again, you go to the table, but this time you check it with the alpha equal to the 5%, but you look at the two-tail area. Two-tailed. Okay, that's a two-tail area only. But to be careful, it was get the correct position. Okay, so in the two-tail area, you get that matching numbers that you want to check. You see, look at this one. True tail area is the second part. You see, that's a true tail area. Okay, that's a true tail area. Identify the alpha of the pi percent. This is the alpha of the 5%. Okay, now you have the DF of 14. So get the DF of 14. This is DF of 14. You see, that's the DF of the 14 and the alpha of the 5% in the two tail area. Alpha of the 5% two tail area. So the reference number is going to be 2.145. 2.145. You see, 14 two tail area. 2.145. So this number is going to be 2.145. You compare it with your T0. Your T0 is 2.655. So it's greater than. So you compare this together. When it's greater than, you have to go to the right. Because when you go to the right, the number is getting bigger and bigger, and your number is bigger. So your P must be here this time. So your P is to the right of the alpha. So you go to that table again. You see the two-tail area. That's a two-tail area. And this is your 5% here. So read any number to the right. Compare that. You see the first number to the right, 0.2. So your 5%, this is 2%. So this means P is less than alpha. Okay, you identify the position of the P and then you compare. So the conclusion is going to be P is less than alpha. Or just use it, use your calculator to find it. Okay, so the conclusion is going to be, conclusion is the fact that the P is less than alpha. P less than alpha, you know that you reject the H naught. Reject the H naught means you support the H1, which is the claim. Okay, so reject the H naught means there is sufficient. There is sufficient evidence to believe otherwise. To conclude, okay, to conclude that mu is not equal to the 51 cent. And it's clear, you see, that was the price in 1998. Now it's 2000. Okay, 2022. So the price of the bananas are going to be different. So this is the one, of course, you support the claim. Support the claim. And with that. Okay, so two cases, make sure don't miss it. This is when the sample is given to you. Then, and another easier one is if everything is already given to you, okay? That's a problem number 9. I won't get time to do it. I'll just give you the numbers and you check it for yourself. Okay, the last problem that we have. You see this one? The information is given to you. You see that's regarding the, okay. So the S is given to you is, S is 1.15% or just 1.15, and they ask for the question they're going to have. So the difference is that in the previous one, you have to use your calculator to find the X bar and the S. For this one, no, it's already there, okay? So I just show you the setup because I won't get time to do it, and then you check it for yourself. Okay, so quickly, this is the number 9, and if you don't have time, I posted, you can see it. So that's a claim. The claim is going to be the mu is greater than 4.19. And you have this information, sample data. You have the sample size of n equal to the 16, the X bar of 5.11, and the alpha of the 5%. And you do have the S, you don't have to find that. S is given to you. Okay, you set up your test. So the H naught is the fact that mu is equal to the 4.19. H1 is that the mu is greater than 4.19. It's a right tail test. Okay, it's a right tail test. So the test stat is going to be T test statistic. Sigma is unknown. Sigma is unknown, but S is given. It's a 1.15. So you have to use the T naught. So you have the T naught, which is going to be X bar minus mu naught over S over radical N. You substitute this number. Okay, you get 5.11 minus 4.19, and you get 1.19, 1.15 over radical 15. So that gives you 3.2. So the T naught would be 3.2. Okay, it's a right tail test for the p-value. Okay, it's a right tail test. Right tail test. So what you have to do is you are going to find the n is equal to the 16. df would be 15. And you compare it with the alpha equal to the 5% in the one tail area. One tail area. Okay, the reference number is going to be 1.753, but your number is 3.2. You go to the right, the alpha over here, P on the top, and the P would be less than alpha, reject H naught. Okay, so it's like the previous one. So the conclusion is going to be that you reject H naught, so there is sufficient evidence to believe the other one. Sufficient evidence to conclude that mu is greater than 4.19, which is the claim. Support the claim. Support the claim. So it's very, very similar. Okay, so that gives you the solution of all of them. It's very important, I told you, read this quiz carefully, and the 6 questions from this quiz would be given to you on the final. Okay, that's it. So read it, and you need I'll post this one, if you want to just repeat it. Sorry, because I have a class, I have to go. Okay, so I'll post some problems for you, but we collect the problems and we give you time up to the end of the course because we have a couple of more things to do. So we want to have all the problems, okay? I've already know, I'm sorry about it. I've already updated the problems. I told you, I just changed all the deadlines to the end of the course. So you shouldn't have any difficulty for those problems that we have, okay? Up to the 25th, again, that's the one. Okay, any question? Just read it carefully. Let me know if you have any question. Otherwise, 6 questions, okay? 6 questions. Confidence interval for the proportion, confidence interval for the standard deviation, and 4 questions on the test hypothesis for the mean. 2 questions when the sigma is given to you. 2 questions when the sigma is unknown. The z-test and the t-test, exactly like I did today. Okay, take care. Have a good one. Bye-bye.